Hello friends, welcome to the online classes of Triveni Memorial Senior Secondary School. Today I am back with the new topics, and today's topic is, as written on the board, is fringe width. And as in the previous topic we have studied about the Young's double slit experiment, we have also studied about the constructive and destructive interference, and we have also calculated the condition for the constructive and destructive interference. Now in this topic we are going to calculate the fringe width, that what will be the width for the bright fringe as well as for the dark fringe. And I am going to start with the diagram. First of all, we try to understand the diagram. So here, as we can see, that there are the two sources of light, S1 and S2, which are placed between the two slits S1 and S2 respectively. Here we have kept the coherent sources of light. Now again I am going to discuss about the coherent sources of light. What are the coherent sources of light? The sources of light which have the same frequency, they are traveling along the same same path or same direction, as well as they are going to have the zero phase or the constant phase difference. These type of sources of light are called as coherent sources of light. Now over here we can see that we have to calculate the path difference, as here the two waves which are just propagating from here, they are intersecting at point P, interfering with each other, just give rise to the fringe. Which fringe? We don't know, whether it is a bright fringe or a dark fringe. Just we are going to calculate the path difference between the two waves here. So here if we want to calculate the path difference between the two, it can be simply given by S2P minus S1P, because if this is the path length for the first wave and this is for the second wave, so just get the difference between the two and we are going to get the path difference, how much this particular wave have traveled the more distance. Now here we have just point out the 3 points, as you can see, A, O and B. Here O is the center of the two slits, so the two slits are separated by the distance D, and here O is the center, so it is having the distance O to A is D by 2 and O to B is also D by 2. Similarly, we have taken the distance from center O to point P is x. Now here in the geometry, as you can see that we have the two right angle triangles, that is S1 BP, similarly S2 A and P. So as we have to calculate the S2P minus S1P, which is the path difference, so simply we are going to use the geometry. Here we are going to you can say apply the Pythagoras theorem in the two right angle triangles, and we will try to calculate the S2P square as well as S1P square. So from the first triangle, that is S1BP, we are going to calculate the S1B square. So S1B square is given by S1B square plus PB square, and mark it as equation number 1. And similarly from the triangle S2AP, we get S2P square is equal to S2P square S2A square plus PA square, and mark it as second equation. Now from here we can calculate the S2P square minus S1P square. So obviously if we are going to apply the identity as A square minus B square is equal to A plus B and A minus B, and simply we are going to get there S2P minus S1P, which is our desired result. So we are going to subtract now equation number 1, this equation 1 from equation number 2. So we are going to get S2P square minus S1P square is equal to S2A square minus S1B square, where S2A square minus S1P square plus PA square minus PB square. So from the geometry we will see that the distance, that is S2A as well as S2 you can say B, is nothing but this is D square minus D square. If we are going to replace the value of S2A square minus S1B square, it will be D square minus D square, that is the distance between the slit and the screen, capital D. So it is going to become 0, and similarly in the next term we are going to place the value for PA square minus PB square. So what is PA square here? So if we want to calculate PA is nothing but PO plus OA. So PO is x and OA is nothing but D by 2. So we are going to get x plus D by 2 ka whole square. Similarly, when we are going to calculate the PB square, so over here we have to calculate PB first. So PB is given by x minus D by 2. So it is going to be x minus D by 2 whole square. So here we are going to calculate these two terms here. So it will be x square plus d square by 4 plus 2xd by 2. So 2 get cancelled out here. It will be simply xd minus x square minus d by 4 square. So here x square get cancelled out, and d square by 4, d square by 4 also get cancelled out. And here again 2 by 2 get cancelled out. It will be plus xd. So xd plus xd will become 2xd. Now I have to rewrite the board. So I will take just fraction of seconds. I will be back. Thank you. Now I have just rewrite the board. Now I am just going to start with the same point as we have calculated. S2p square minus S1p square is equal to 2xd. Now here we can use the identity of a square minus b square, that is nothing but is equal to a plus b, a minus b. Clear? So a plus b is S2p plus S1p into S2p minus S1p. And what we are supposed to calculate? We are supposed to calculate S2p minus S1p, which is nothing but is equal to now 2xd by S2p plus S1p. So we are simply going to call it as path difference. It is denoted by the small p, or simply by del also you can just notate it. So 2xd by S2p plus S1p. Now we are going to assume that S2p is similar to S1p is similar to capital D. That is the distance between the screen and the slit. So here it will become d plus d, that is 2d. So 2 get cancelled out, and it will be xd by d. So path difference is simply given by xd by capital D. Now if we have to calculate the position for the bright fringe, if we will be able to calculate the position for the bright fringe, simply we are going to calculate the fringe width of dark fringe. So because between the two consecutive bright fringe, we are going to have the, in the center middle, we are going to have the dark fringe. So we can calculate the fringe width of dark fringe. So here the path difference is given by xd by d as we have calculated from here, and also we have calculated the condition for the constructive interference. If we are going to locate the position for the bright fringe, so it should be equal to n lambda. That we have calculated in the Young's double slit experiment. For that you have to just go through by my previous video, in which we have discussed about the Young's double slit experiment and the constructive and destructive interference conditions. So over there we have calculated the path difference is equal to n lambda. Now xn will be given by n lambda d by d simply. So x naught at n equal to 0, we are going to get it to be 0 only. Position at n equal to 1, we are going to get as lambda d by d. Similarly at x2, that is n is equal to 2, we are going to substitute here. We are going to get 2 lambda d by d. Similarly xn will be given by n lambda d by d. Now if we are going to subtract x1 minus x0, we are going to get lambda d by d. Similarly, we are going to subtract x2 minus x1, again it is going to result in lambda d by d. Similarly, we have calculated the fringe width of dark fringe. From these two bright fringe, if we want to calculate, we are going to get the fringe width of the dark fringe. Always remember, between the two bright fringe, we are going to have the dark fringe, and we are going to calculate the width for that. So obviously between the two consecutive or successive bright fringes, we are going to get the dark fringe. So for that particular width, we have to subtract the two consecutive positions of the constructive, or the, you can say, bright fringe. So similarly, we are going to get xn minus 1. So here again, by subtracting these two, we are going to get the condition as lambda d by d. So fringe width for the dark fringe is given by lambda d by d. Similarly, we are going to calculate the, you can say, condition, or first of all we are going to calculate the position for the dark fringe, similarly in the same way only, and after that we are going to calculate the you can say fringe width for the bright fringe, because for the consecutive dark fringes are going to have the in between the bright fringe, so we have to calculate the fringe width for the bright fringe also. So here we are going to just substitute the value for the dark fringe condition. So path difference, if we are going to calculate in terms of dark fringe, it will be 2n minus 1 lambda by 2. So I'll rub this part, and again I am going to write the position of the dark fringe. So I will be back in fraction of seconds again. Thank you. So now I am going to start with the position of the dark fringe. So for calculating the position of the bright fringe, again I am supposed to calculate the, you can say, substitute the value for the destructive interference condition, and that we have got as p is equal to 2n minus 1 lambda by 2 as rewritten here. So from the this particular derivation where we have to locate the position for the dark fringe, we have got xn D by capital D is equal to 2n minus 1 lambda by 2. Now we are going to get xn, which is the position for the dark fringe, is given by, or you can put it as dash, because for both we cannot take the same notation, so we can take it as dash. So it will be equal to 2n minus 1 lambda d by 2d. So x1 dash we can get lambda d by 2d, x2 dash we can get 3 lambda d by 2d. Similarly, x3 will be 5 lambda d by 2d, and xn will be 2n minus 1 lambda d by 2d. What we have to calculate again, subtract the two consecutive one. So x2 dash minus x1 dash, or x3 dash minus x2 dash, or xn minus 1 dash. What we are going to get again, beta dash is equal to lambda d by d. So from here, from the two consecutive dark fringe, we are going to get the fringe width of the bright fringe, and here we have got the fringe width of the dark fringe. So this is how we can calculate the fringe width of the dark as well as for the bright fringe. And as we can see that in Young's double slit experiment, we are going to get the fringe width to be constant, which is for the bright fringe or for the dark fringe is lambda capital D by D, where lambda is the wavelength, capital D is the distance between the screen and the slit, and small d is nothing but the distance between the two slits. So I hope my videos are helping you out a lot. So thank you so much. I will be back with the new video which is called as diffraction of light.